In this video, we're going to work on the ALEKS problem called Interpreting a Skeletal Structure with Aromatic Rings. So this problem will give us a line structure or a skeletal structure. It wants us to come up with the molecular formula for the molecule and then indicate how many CH3, CH2, and CH groups there are. So the number one trick, I think, with this problem is knowing what to make of this notation. This six-membered ring with the circle inside of it, that is a shorthand or an abbreviated notation for a benzene ring, which is a six-membered ring that has alternating double single bonds. So that's what this notation indicates. And again, this is just a fast way to draw the three double bonds in the benzene ring. And it is a lot of times for a lot of students, it's easier to think about the molecule in this notation until you get kind of familiar with it. So I'm going to redraw the molecule using this double bond notation. First question wants to know the chemical formula. So to figure that out, we're going to count up how many carbon atoms we have in this molecule. That's 6, 7, 8, 9, 10. So this is a C10. And then we need to come up with the number of hydrogen atoms in this molecule. Remember that every carbon likes to have 4 bonds. And so any carbon that has less than 4 bonds drawn in the line structure is going to have hydrogen atoms attached to it, as many hydrogen atoms as it takes to get the carbon atom up to 4 bonds. So for example, if we look at this carbon atom right here, we can only see one of its bonds. That means that it must have 3 hydrogen atoms attached to it because it likes to have 4 bonds. This carbon atom here has 1, 2, 3 bonds. Double bonds count as 2. So it has 1 hydrogen atom. And same with the carbon next to that. This carbon atom has 2 bonds showing, which means it has 2 hydrogens. This carbon atom has 1, 2, 3, 4 bonds. It does not have any hydrogens at all. This carbon atom has 1, 2, 3 bonds, so that means it's got 1 hydrogen. And that is true for all of the other carbon atoms in this benzene ring. Why did we do that? We're working on the chemical formula, so we need to know how many hydrogens there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C10, H12. And notice the notes that ALEKS is giving you on how it wants this represented. It says each element symbol appears only once. That means it doesn't want it in a condensed formula. It wants just carbon and how many carbons there are, hydrogen and how many hydrogens there are. It doesn't want something like CH3, CH2, CH2, something like that. Don't do that. Okay, now it wants us to figure out how many CH3, CH2, and CH groups there are in this molecule. Well, we've got right here, there's a CH3 group, and that's the only one that I see, so there's only one of those. CH2 is going to be a carbon with 2 hydrogens, and we've only got one of those. And a CH is going to be a carbon with 1 hydrogen, and we've got 1, 2, 3, 4, 5, 6, 7 of those. This carbon atom right here that has no hydrogens on it, it is not showing up in this part of the problem. There isn't a space here for us to indicate how many carbon atoms with 0 hydrogens. So that's why, even though we know we have 10 carbon atoms in the molecule, we've only accounted for 9 of them in this second part of the problem.